Hello, students. Today we are going to see this new topic, which is known as written statements. Okay. So in the last class, we have seen this scope and anonymous function, everything. Okay. So scope of a variable means the accessibility of a variable. So where you can access the value of a variable is determined by this scope of variable. And anonymous function means the function which doesn't have this. Uh, yes, anonymous function means the function that doesn't have the name. Okay, so this is what we have seen this up to last class. So today we are going to see this written statement. So you can see that the return statement means after the function finishes its task, it has to return the output to the calling statement. Okay, so here you can see that the function will be called uh, by a calling function, and then uh, the value will be transferred from the main function to the calling function. Then the input will be processed, and an output will be generated. So this output will be should be transferred to the statement where it has been called. So this output statement denotes that this function has finished its task. So that is the purpose of return statement. You can see that the return statement causes your function to exit and return a value to its caller. The position of the point of the function is generated to take input and return something. So it is getting some value from the caller, and it is returning some statement or returning some value to the caller function. Okay, the return statement is used when a function is ready to return a value to its caller. So only one return statement is executed at runtime, even though the function contains multiple return statements. So here you can see that the function may contain so many return statements, but at the runtime it should execute only one return statement, meaning uh, you can see that the function may have some kind of decision making statements, so that at the end of the function it will return only one value. Okay, uh, return only one value or particular value, so that uh, the the receiver end of the output will get the required output. Okay, uh, any number of return statements are allowed in the function definition, but only one of them is executed at the runtime. Syntax of a return statement: return is a keyword, and the expression, it can be any variable name, or it can be any value, or it can be any output arguments, objects, anything like that. Okay, so the this statement can contain expression which gives uh, which gets evaluated and the value is returned. If there is no expression in the statement, or the return statement itself is not present inside the function, then the function will return the none object. So only a return keyword is there, but there is no value, or there is no output to the caller. Then then the compiler will automatically take it as none object, and the none object will be sent. If there is no return statement also, then the compiler will take it as none object and send it to the receiver end. So here you can see that they are given on a example for return statement diff usr underscore abs. So n is the input. So if n is greater than 0, return n, else return minus l. So here you can see that if the n value is greater than greater than 0, you can take it will return n, or else it will change the sign of a n value. So x is equal to input integer. Okay, the given input value is converted as integer here, and the input is gathered by denoting the user enter a number. When the user enters some number, it will be stored in x. So now you can see that it is called here print usr underscore abs x. So now while seeing the compiler seeing this statement inside the brackets, it will call the function diff usr underscore abs with the x value. So the x value, say example 25. So the 25 will be given to n is greater than 0, 25 is greater than 0, condition is true, so n is transferred as it is. But here you can see that in the next output minus 25 is given, which is less than 25, less than 0. So else part is executed, return minus n. So minus of minus 25 is uh, positive 25, so you can get the answer as. So after finishing, you can see that there are two return statement here. So if condition n greater than 0 has one return statement, else has return statement. So at the runtime, you can see that only one return statement is executed, so that the output is transferred from there to print statement, and the output is printed. So next is the scope of variable. So already we have seen this scope of variable. So the scope means the scope of variable means it is a part of a program where certain variables are being accessible. So you can see that in some of the uh, programming part, some of the variables cannot be accessed. Okay, so to create a program in a very secure way, they'll be handling these kinds of uh, scoping methods. Okay, so we'll see the different types of scoping and how they work. Scope of variable refers to the part of the program where it is accessible, that is area where you can refer or use it. Okay, you can say that scope holds the current set of variables and their values. We will study two types of scope: local scope and global scope. So there are two types of scope. One is local scope and another one is global scope. So local scope variable declared inside the function's body or in a local scope is known as local variable. So you can see that here in the previous example itself. So x is a variable, so that is a local variable. So here you can see that rules for local variables. Okay, so if you want to use a variable as local variables, then you have to follow this rules. Okay, so a variable with the local scope can accessed only within the function block that it is created in. Okay, so when you create a function, that function has a local variable, then the variable must be accessible only inside this function alone. When a variable is created inside the function block, the variable becomes local to it. A local variable only exists when the function is executed. So the validity of a local variable is when the function or the program gets executed. After the function or variable gets executed, uh, the validity of the variable gets cancelled. The format arguments are also local to the function. The formal arguments means the function or the input given to the function is also the local variable, which means that the calling function will give some value to the function, so that value which is passed from the caller function to the function is also local type. Okay, so here you can see that they are given on example to create a local variable. So diff loc loc. Okay, so here y is equal to 0 is a local scope, and print y. So they are printing the local variable y, and is printing the output as 0. You can see that in the next one, uh, diff loc y is equal to local, and loc is called, and after that, after after uh, after finishing the function, they are they are trying to print the value of y. So here this statement which is accessing the variable y is not inside the scope of local variable. So it is unable to access the variable y. So you can see that you can get an error statement which is known as name y is not defined inside this uh, say the part where it is accessing it. So next thing is global scope. So this global scope, the variable with the global scope can be used anywhere in the program. It can be created by defining a variable outside the scope of all functions and block. So if you want to create a variable with a global scope, then it can be accessed anywhere inside the program. Um, rules of global keyword. Okay, so if you want to use this uh, global scope, then there are some rules, then you have to follow it. So the basic rules of global keyword in Python are: when you define a variable outside the function, it is global by default. When you don't have even if you didn't have to use the global keyword. So before all the functions, you create a variable with uh, variable with some value, then that value or that variable is global when even when you doesn't use this global keyword. So we use global keyword to read and write a global variable inside a function. Use a global keyword outside the function has no effect. So when you want to access or rewrite the value which is inside this global variable, then you can use this keyword global. And when you are using this global keyword outside the function, it has no effect. So we'll see this example. Okay, so accessing global variable from inside a function. So here you can see that c is equal to 1. It is a global variable. It is declared without using global keyword. Okay, now they are creating a function named add diff, a function name add. Okay, so inside that they are printing c and they are calling the function add. Now you can see that the output is created as 1. Okay, output is printed as 1. The next program we can see that accessing global variable from inside a function the same as printed here. Okay, next you can see that modifying. You can see that in this program they are trying to modify the global variable. You can see that it is providing some output as error. Okay, so unbound local error, which means that c is equal to 1 here, and they are defining the function, but without global keyword they are trying to change it. C is equal to c plus 2. So and then they are trying to print it, but before trying to change it you have to use this global keyword. So the output is not provided and an error message is displayed. So in the note you can see that without using the global keyword you cannot modify the global variable inside the function, but you can access it. So changing the variable. So if you want to change the variable, then you can you can see that global x is used here. So x is equal to 0, diff add is the function name, global x will get the global variable, and x is equal to x plus 5. Now the value is changed and it is printed and it is called here. Okay, now there at the end you can see that the main value of x is 5. So in the above program, x is defined as a global variable. Inside the add function, global keyword is used for x, and we increment the variable x by 5. Now you can see the changes of global variable x outside the function, that is the value of x is 5. So combination of this both local and global variables. So they are given some example programs. Uh, so x is equal to 8. Diff local globally x is accessed here. Y is equal to local, and x is equal to x into 2, which is allowed here since we have used the local global x keyword. Global is used with the x. Okay, so x is equal to x into 2. X is equal to 8 into 2. Now the value of x is printed and the value of y is also printed. So you can see the value is 18 and value of x is 8. Value of x is 16 and value of y is uh, local. Okay. In the above program, we declared x as global and y as local in the function. After calling the function local, the value of x becomes 16 because we have used x is equal to x into 2, and after that we print the value of local variable y, that is local, with the same name. Global and local variables with the same name. We'll see what happens here. So x is equal to 5, and that is a global variable, and another one x which is declared inside the function, x is equal to 10. Okay, so this is local variable. Now here you can see that print x and print y. Okay, sorry, print local x, and outside the function you can see that print global x. So the first print shows the local variable, and the second print functions shows the global variable. In the above code, we use the same name x for both global variable and local variable. We get the different result when we put some put some variable, because the variable is declared both scope, that is local scope inside the function, and global scope outside the function. The output is local x 10 and global x is 5. Now in the next topic you can see that these are all the different built-in functions which are available in the Python itself, so that you can use it and directly use it, not by coding it. Okay, just you can use the name and you can give some value to it. It will return the output as it is. Okay, so here ABS means absolute. This will return point values. Here you can see that ABS x, so x is equal to 20, y is equal to minus 23.2. Okay, so they are changing the value as absolute, means it is rounding the value. Okay, changing the negative numbers into positive numbers, so that is absolute. Okay, so ORD means ORD means the given ASCII value of the character. So C is equal to A and D is equal to capital A. So now you can see that they have used ORDC and ORDD. So the C is equal to 97 and A is equal to uh, small a is equal to 97 and capital A is equal to 65. So here there is a small printing mistake. C instead of C, you should take it as a small a. So this ORD function returns the ASCII value of any character given to it. The same opposite is this. Okay, so when you provide any ASCII value to this character, it will provide the actual character of it. Okay, so next is bin bin. So this will convert any given number into the binary value. So x is equal to 15 and y is equal to 101. So when you use it as bin x, it provides 0b. 0b means denoting that the number that is following here is a binary number. So here you can see that format function can also be used instead of this function. So format is another one function that is used to convert the given number into binary number. Next is type. So what type of object or what type of variable it is to know this function, you can use this type function. Okay, so here you can see that there are three different types of values. X is equal to 15.2 and y is equal to a, and s is equal to true. So when you provide this as input to this type function, it provides you that this belongs to float. So 15.2 is float and a is a string, and true or false is boolean. Okay, next is id. Id means this will return the identity of an object, that is address of the object. Okay, so here you can see that this x is equal to 15 and y is equal to a is provided to this id, and this provides some numbers which is the address of x and y, minimum and maximum. So in the given list of numbers, which one is minimum? Okay, so min of my list, here you can see that 21 is the minimum number, it is displayed here, and maximum, what is the maximum number is provided here, and sum, it will add all the elements in the uh, in the list, and it will provide you the output. Yes, this is the format. So in the previous bin function itself, we have seen this is the format one. So here you can see that whatever code you give, it will provide you the required output. Okay, so here you can see that there are two values should be specified here. So one is the value and another one is the format. So there are three types of format. One is binary format, octal format, and fixed point notation format. So here you can see that they have used all the three here. So x is equal to 14 and y is equal to 25. So x comma b, so this 14 will be converted into binary format and displayed in the output, and y comma o means octal format. So this will convert the 25 into octal and display it as a octal number. And the next thing is fixed point numbers. So here you can see that y is only 25, but by default it is given the fixed point is 6 decimals, and you can see that 25.00060 zeros are provided uh, to denote it as even more precise. Next is round. So this function, as the name itself, you can see that number of digits, if you want you can provide it. Okay, so there are two variables, two values should be given. One is optional. Okay, first one is number and the next one is number of digits. So here you can see that 17.9, 22.2, minus 18.3. So these are all the number given as an input to this function, and the output is provided as 18, 18, 22 and minus 18. So here you can see that n1 is given, and n1 comma 0 means it will convert as total rounded and provide you as 18. 17.889 as 1 means it will consider only one part and convert it as 17.9, and 2 means it will consider two numbers after the decimal point and it will print as it is as 17.89. Next is power. Next is power function. So here you can see that a is equal to 5, b is equal to 2, and c is equal to 3.0. Power a comma b means a to the power b. So 5 to the power 2 will be considered, and 25 is printed. A to the power c, a to the power c is 2 into 3.0, which is 125.0, and a plus b comma 3 means a plus b is 7 to the power 3 is used here, so that is 343. Next is some of the mathematical functions. Floor means it will round of the larger return the largest integer less than or equal to x, so it will reduce the value, so which means that less than. So here you can see that 26.7 is rounded to 26, and minus 26.7 is rounded to 27. So you may get confused why 27 means. So 27 is less than 26, okay, minus value. So here you can see that next is minus 23.2, which is also you can see that minus 24. Next is seal means ceiling, math.seal.x. Okay, so this is also returns the smallest integer greater than or equal to x. Okay, so it will take uh, greater values. Okay, so x is, you can see that 27 is rounded off, and 26 is uh, used here, and 23 is also used here. So this will take the greater value. Next is, you can see that square root. So this square root will provide you the square root of given number. Sqrt is the function, and you have to give the input to it, so that you can see that it is providing you the square root of the function. Next is composition in functions. So what is composition? A value returned by a function may be used as an argument for another function in the nested manner. So this is called composition. For example, if you wish to take a numerical value or an expression as an input from the user, you can take the input string from the user, use the function input, and apply eval. So eval function to evaluate the value. For example, uh, this composition function is used to provide the output of one function as an input to another function. So we'll see an example here. So n1 eval input eval input enter some number. So here you can see that the user enters one number and it is stored in n1, and you can see that n1 is printing the value as 234, and n2 eval input enter an arithmetic expression. So the user is entering some expression 12.0 plus 13.0 to the power 2. So the n2 is 38.0. So you can see that you can provide some value as well as some expression in it. Okay, so this is known as composite composite function. You can see that eval is the function that is used to create composite function. The last thing is Python recursive function. A function which calls itself is known as regression. So this regression works like loop by some, but sometimes it may it makes more sense to use recursion than loop. You can convert any loop into recursion. So the recursive function calls itself imagining a process while iterating indefinitely. It will not stop by some condition such a process is known as infinite iteration. So the condition that is applied in any recursion function is known as base condition. This base condition is a must in every recursive function, otherwise it will continue to execute like an infinite loop. So if you are creating a recursive function, you have to be defined with the base condition. If you not provide this base condition, then this recursive function will not stop and it will keep on executing. Okay, so overview how to use this recursive function. This recursive function is called by some external code. If the base if the base condition is met, then the program is given meaningful output and execute. Otherwise the function does some required process and then it calls itself to continue a regression. For example, fact, define fact. So fact n is if n is equal to 0, return 1, else return n into fact of n minus 1. So here this n into fact of n minus 1 is calling itself. Okay, so here fact of 0 is 1 is printed. Next is fact of 5 is when it comes to else part, 5 into fact of n minus 1, which is 5 minus 1 is 4. So it is 4, it is calling again. Okay, calling its function again. So at the end 5 into 4 into 3 into 1 will be uh, gathered. Okay, 0 means it will take it as 1. So 5 into 4 into 3 into 1 into 1. So after that the condition gets false and it will print it as 120. So you can see that print fact of 2000 will give you runtime error maximum recursion deep depth exceeds in the comparison. This happens because the Python stops calling recursive function after 1000 calls by default. It is allowed you. Uh, it also allows you to change the limit by using sys.set recursion limit to the limit value. So by default, the Python will only call the regression function only 1000 times. But if you want to make it as make a change to 3000, then you can do it by using this um, sys dot set regression limit in this program. So here you can see that import sys is used here. Sys dot set regression limit is equal to 3000. So after that you can see that they are using the same function and you are getting the regression value. Okay, so the output is not given, it will be very big number. Okay, so with this we'll finish the class today. We'll see the rest of the things in the next class. Thank you, students.